Hey there, ladies and gents, boys and girls. This is Mr. D here. Today we're going to be talking about arithmetic sequences and getting into explicit formulas for arithmetic sequences. So first and foremost, if at any point you need to pause this video, please feel free to do so if there's something you want to write down. For instance, right now, all of this text, if you need to write anything down, maybe paraphrase it for your personal notes, not a terrible idea. All right, so first, an arithmetic sequence is any sequence, so a list of numbers, where the difference between terms is constant. So that means we are either adding or subtracting. So we are either adding or subtract. This is what's called the common difference. Whatever quantity you are subtracting or adding from each term to get to the next is called your common difference, and we use the letter D to determine that. D, or the common difference, is found by taking any term and subtracting the term before it. So, essentially, the common difference is what are we counting up by or what are we counting down by? Here I have a sequence of 142, 146, 150, so on and so on. I'm counting up by 4s, therefore my common difference is 4. -5, -2, 1, 4, 7. I'm going from negatives to positives, so I'm counting up. My difference here is a positive 3. The next example, 8, 3, -2, -7, -12. We are counting down. We're going from positives and ending with negatives. I should hesitate to use the word ending because these dots means it goes on forever. But regardless, our difference would be -5. So we are subtracting 5 to get to the next term. So arithmetic sequences can only be considered arithmetic if it's a strict adding or subtracting each time. So let's see some examples here. For the first one, well, first, let's say we want to determine first, is it arithmetic? So yes or no. And then if so, what is the common difference? To go from 2 to 4, I add 2. So the next term should be 6, and it's not. Here it looks like I'm multiplying. Well, multiplying would not be arithmetic. That would be geometric. And that is a topic for a different day. Let's try B. To go from 3 to 6, we're adding 3. Plus 3 is 9, plus 3 is 12. So this one works out. My difference here is 3. To go from 1 to 5, I add 4. Plus 4 is 9 plus 4, so that works out. Our difference here is 4. Looks like for part D, 1 to 3, I'm adding 2. 3 plus 2 is 5, yep. Plus 2 is 7, good. So we are going up by a constant amount. Let's go 3 to -3. I'm taking away 6. That's a 6, not a C. Then if I take away 6 again, -3 minus 6 is -9, so that works out as well. So my common difference there is a -6. So pretty straightforward for identifying whether or not it's arithmetic. Now let's get into the formula here. This would be a great spot if you wanted to pause. The explicit formula, explicit meaning I can figure out explicitly any given term without knowing any terms before it, is listed as a sub n, or the nth term, is the same as saying the first term, which is denoted by a sub 1, plus n minus 1 times the common difference of d. Now the reason why this works is, let's say I have the sequence of 3, 5, 7, 9, so on and so on. My first term here is 3. Then 5 I could really list as 3 plus 2. And then 7 I could really list as 3 plus 2 plus 2. And then 9 I could list as 3 plus 2 plus 2 plus 2. So the number of 2's, or the differences that I'm adding on, is always going to be one less than the term number. Because 3 was my first term, 3 plus 2, or 5, was my second term, 3 plus 2 plus 2 was my third term, so on and so on. So the number of differences being added is always going to be one less, one fewer than the term number, and that's where that n minus 1 portion comes from. So here we have an example. Find the explicit formula for the nth term of an arithmetic sequence. The common difference is 3, so they give us a d value. And a first term is 2, so they give me an a sub 1. So I'm going to plug things into my formula here. We're trying to find a sub n. It's going to equal a1, which is 2, plus n minus 1 times my common difference of 3. So all I've done is plugged in a sub 1 and d, and now we're going to distribute in, combine like terms, and simplify to be done. So I'll have 2 plus, that'd be 3n minus 3. Combining like terms, I get a sub n equals 3n minus 1. If you had those terms backwards and wrote negative 1 plus 3n, it is the same thing. All right, next example. Given a following sequence, we want to find the 35th term. So that means we are trying to find a sub 35. We know the first term here is 5. And we know the difference is, let's see, to go from 5 to 8 to 11 to 14, the difference is 3. The common difference is 3. So I can plug in everything I have. An important piece of information, though, is they're telling me a specific term number to find. So that gives me an n value. If I'm finding the 35th term, my n value is 35. So again, using this formula, I need to find a sub 35. I know a1 plus, we know that that was 35, and our difference down here was 3. So a sub 35 is going to equal 5 plus, let's see, 35 minus 1 times the difference of 3. And you guys can just skip that step mentally. If you want to write 34, go for it. So a sub 35 would equal, let's see what that turns into. Handy dandy calculator. We've got 5 plus 34 times 3, 107. So the 35th term in that sequence would be 107. And if I really, really, really wanted to double check, I could list out all of those numbers until I hit the 35th one. But that would take forever, and I don't feel like doing that. Let's do one more of these. We want the explicit formula first, given the sequence, and then we want to find the 100th term. So this is kind of a two-parter. First, I need to find the formula, and then I need the 100th term. So over here, I'm going to do the formula. Over here, we'll calculate the 100th term. Let's see, 6 is a sub 1. And if I go from 6 to 11 to 16 to 21, my difference is 5. So the explicit formula states a sub n equals my first term of 6 plus n minus 1 times my difference of 5. This 5 will distribute in, we'll combine our like terms. To get the formula, a sub n equals 5n plus 1. Now, if I wanted to find the 100th term, I can just take 100 and pop it into there. So the 100th term, a sub 100, will equal 5 times 100 plus 1, 501. And that's it. Let's go to the back side here. We want to know what are the second and third terms of this following arithmetic sequence. We want to write the explicit formula given this term. The next example down is the exact same, so for time's sake, we're just going to be doing one of these as a heads up. First, I know that a sub 1 equals 100. This would be a sub 2, have no idea what it is. This would be a sub 3, no clue what it is. And then they tell us a sub 4 is 82. So I don't know what I'm counting down by, but clearly my difference, the common difference, should be a negative something, because I'm starting at 100 and ending at 82. Well, let's use this formula here for a sub 4. A sub 4 would be equal to my first term plus 4 minus 1 times the difference. Well, I know a sub 4 was 82. I know a1 was 100. I know 4 minus 1 is 3. So 3d. So now to solve, I'd subtract 100 to the other side. I'd get negative 18 equals 3 times the difference. Therefore, the difference equals negative 6. So to fill in these missing values here, after 100, if I took away 6, would come 94. Take away 6. Why did I put a negative there? Take away 6, you would get 88. Take away 6, we'd get 82. Also, now that we know the common difference, we can go through and set up our formula. To find the nth term, we would take our first term, 100, plus n minus 1 times our difference of negative 6. Distribute that in, make it look pretty. We've done that before. Let's do one more kind of challenging problem here, and then we'll call it a day. So here we have the fourth term of a sequence is 20. So I'm going to write that down. A sub 4 equals 20. The 13th term is 65. A sub 13 equals 65. Write the explicit formula for n and then find the 30th term. Holy smokes. All right, so let's go through and tackle this. We're going to use the same logic that we used up here, by the way, where we don't know the common difference, and that's what we're going to be seeking to find. We also don't know the first term, so there's an issue there in itself. But I do know that a sub 4, which is 20, equals whatever my first term was, a1, plus 3 times the common difference. Then I have my 13th term, which was 65, and that's going to equal whatever my first term was, plus 12 times the common difference. And remember, these values here are always 1 less than the index number. And the way this is set up right now is absolutely perfect for a little bit of elimination. So I'm going to think of this as a system. If I made everything in that top equation negative, I would get, let's see, negative 20 plus 65 is 45. A1s cancel out, and then I get 9 times D. Therefore, the difference would equal, let's see, 45 divided by 9 gives me 5. Well, if I know the difference is 5, I can go back to one of the equations. I'm going to use the top one. 20 equals A1 plus 3 times D. In this case, D was 5. And I can work backwards and figure out my first term was now 5. So from here, we can get the explicit formula. We know D, we know A1. Those are the two components, the two ingredients we need to have. So the explicit formula states, to find the nth term, I need my first term, 5, plus n minus 1 times my difference, also 5. We'll distribute in, and we will have a sub n equals, let's see, 5 plus 5n minus 1. So this is actually going to work out to just be 5n. And then if I wanted the 30th term, a sub 30 would equal 5 times 30, or 150. So I actually kind of took you through the long way to do that. The shortcut to that would be, well, if I go from 20 to 65, I've advanced 45 units. And if I went from the 4th term to the 13th term, I've gone 9 steps, or 9 differences away. So spanning 9 differences accounts for 45 units. And that's exactly where this equation came from. So to go from here directly to here, there is kind of a mental shortcut, just as a friendly heads up. All right, so that is the bare bones basics for these. You might see some application problems, and for time's sake, we won't get to it, but it's going to be the exact same scenario. They just tell you A1 and A2, and you can go on to find those from there. But as long as you're getting in the habit of whenever we solve these, let me find it, of always seeking to find A sub 1 and D, you should be absolutely fine. If they ever give you, say, the 13th term or the 30th term, an A sub n, please keep in mind that that will also give you an n value as well. So that's kind of a 2-for-1 deal. As always, if you have any questions, please do not hesitate to reach out. Good luck, have fun, be safe, roll tide.